4 September 2018. A typhoon drives a wall of water across Osaka Bay and into the seawall of an airport that has no land beneath it, only an island that people built. Waves burst over the rim. Seawater floods the runway and the apron, spreading beneath parked aircraft. The sea is taking the airport back. Rewind 30 years. Osaka Bay is flat and gray, 5 kilometers of open water between the shore and nothing at all. There is no island here. There is only a problem the city of Osaka cannot solve on land, and a plan to solve it out at sea. Osaka's old airport at Itami sat inside the city. Houses pressed against the fence line. Residents went to court over the noise, and night flights were restricted. The airport could not grow, and it could not stay open around the clock. The region's economy needed a gateway that never closed. So, engineers proposed something audacious: move the airport offshore, far enough that no one would hear it. Build a new island in open water. Link it to the mainland by a single bridge, and run it 24 hours a day. Japan had reclaimed land before, never on this scale, and never this far out. The chosen site lay about 5 kilometers off the Senshu coast, in water roughly 18 meters deep. Far enough for silence, close enough to connect. The island would measure some 4 kilometers long and 2.5 wide, a rectangle of engineered ground where there had never been ground at all. But the bay floor was not rock. Beneath the water lay a thick blanket of soft marine clay, laid down over thousands of years, saturated and slow. Press down on it, and it doesn't shatter. It squeezes. Water is forced out of the pores. Grain settles against grain over decades. Engineers call this consolidation. Load the clay and it compacts, but only as fast as trapped water can escape. And water escapes from clay agonizingly slowly. Left alone, the island would have kept sinking for a century. The team could not stop the settling. They could only decide when it happened. Their answer was to give the water a shortcut. Across the whole footprint, roughly 1 million vertical sand drains were driven down into the clay, columns of sand offering a short path upward. Squeeze the seabed now, and decades of settlement could be compressed into a few years. First came the perimeter. A seawall, roughly 11 kilometers long, was built out in open water, rock and concrete blocks laid on the prepared seabed, enclosing empty sea. For a time, it was only the outline of an island, a rectangle of surf with nothing inside it. Then they filled it. Mountains on the mainland and on nearby islands were quarried away, hillsides cut down and carried to the coast. Over 100 million cubic meters of rock and earth were needed for the first island alone. Landscape moved, wholesale, into the bay. A fleet of barges ran day and night, loaded at the quarries, hauled across the bay, emptied into the water inside the wall, and sent back for more. The work ran for years without pause. Beneath it all, the clay began to give, exactly as predicted. By 1989, the seawall was closed. Then, slowly, a gray plain rose above the waterline, flat and raw and utterly artificial. Trucks crossed ground that had been open sea. Surveyors set out the lines of a runway on land that was still, measurably, moving downward. And it was moving faster than anyone had forecast. The deeper layers, assumed to be far more stable, compressed as well. Settlement expected to unfold across 50 years arrived in a fraction of that time. The island was sinking in the direction predicted, and by far more than predicted. By the late 2000s, the first island had settled roughly 12 meters from the original seabed level, several meters more than the design had assumed. That was not a failure of construction, it was a limit of prediction. No one had ever loaded this much clay this heavily before. The island needed a lifeline. A double-deck bridge, about 3¾ kilometers long, carries road traffic above and railway tracks below, striding across open water on steel trusses. It is the only fixed link. Everything the airport consumes crosses it. For the terminal, An international competition was won by the Italian architect Renzo Piano. His building would run more than 1.5 kilometers from end to end, the longest airport terminal in the world when it opened. A single sweeping wing laid along the island's spine. The roof is a long, asymmetric arc, clad in tens of thousands of identical stainless steel panels. Inside, the Great Hall has no enclosed ducts across its ceiling. Air is thrown along the curve by open nozzles, the shape of the roof itself guiding the flow. But the real innovation was underneath. The terminal stands on roughly 900 columns, and everyone sits on a jack. When part of the building sinks faster than the rest, crews raise that column and slide steel plates beneath the base plate. The building is leveled by hand, forever. Kansai International opened on the 4th of September, 1994. Across island, bridge, rail, and terminal, the cost ran on the order of $20 billion. Aircraft landed on ground that had not existed a decade earlier, at an airport that would never have to close for the night. 4 months later, on a January morning, the Great Hanshin earthquake devastated Kobe, some 30 kilometers away. Thousands of people died. The airport island, built on soft clay in open water, came through without structural damage and flew relief in. The engineering was tested far sooner than anyone wanted. Living with settlement shapes everything. Pipes and cables cross the island in flexible joints. Runways are resurfaced and regraded as the ground drifts. Survey points are read again and again, year after year, so that the island's shape is always known and always changing. Demand kept climbing, and one runway was not enough. A second island was begun beside the first, in water even deeper, adding roughly 500 hectares of new ground. This time the engineers built with everything the first island had taught them about clay. They overbuilt for settlement, piling the fill higher than the finished level, so that as it sank, it would arrive where it was meant to be. Runway B, 4,000 meters long, opened in August 2007. Kansai could finally handle its traffic around the clock. The second island sinks too, and being younger and in deeper water, it sinks faster. Both are watched continuously. The first has slowed to a few centimeters a year. The settling curve flattens, but it never quite reaches zero. It simply becomes something to manage. Then came the 4th of September, 2018, 24 years to the day after the airport opened. A typhoon pushed a storm surge into Osaka Bay higher than the island's defenses. Water overtopped the seawall and flooded the older runway, the basement levels, and the electrical equipment beneath the terminal. Out in the bay, a tanker riding at anchor was driven by the wind into the connecting bridge, tearing out a span of roadway. The island's only fixed link was severed. Thousands of passengers spent the night stranded on ground, surrounded by the sea that had just crossed it. They evacuated by boat and by bus across the surviving deck. Within weeks, flights resumed. Within months, the bridge was whole again. Then came the harder lesson. The seawall was raised, critical equipment was moved above flood level, and watertight doors were fitted. Settlement had quietly eaten the design margin. That is the quiet arithmetic of Kansai. The island goes down. The sea, across this century, is expected to come up. Two slow curves converging on the same line, and the only answer is to keep raising the wall and to keep reading the instruments. Civil engineers named it one of the monuments of the millennium. It deserves the title, though not for permanence. Kansai's achievement is that it works at all. A piece of ground invented from mountains and clay, holding an international airport steady while it settles beneath its own weight. We tend to imagine great engineering as something finished, poured, sealed, done. Kansai is the other kind. It is a structure kept alive by attention, measured and jacked and resurfaced and raised, an island still arriving at its final shape, one careful millimeter at a time.